We hope you enjoyed the Stay Up lab. Let's take a look at the concepts that you learned. In this lab, you learned that a hypothesis is not enough to support a scientific claim until you test it with experimentation. In the lab, you designed paper airplanes based on what you thought would glide the farthest, but without testing it, you would have no idea which design was best suitable for longer flight. Eventually, you discovered that the longer the wings were on the plane and the lighter the plane, the longer it would glide. Believe it or not, this is the same process that gave us the airplane altogether. Since ancient Greece, humanity has dreamed of having the ability to fly. Most of the early models of gliders resembled birds and only flew about a few hundred feet. It wasn't until 1905 when Wilbur and Orville Wright had the first sustained and controlled heavier-than-air flight. Although the Wright brothers' craft was just a glider with a propeller, it set precedent for all other aircraft. In World War I, the airplane really became what we know today. The US was experimenting with them at first for reconnaissance, and then later as a weapon. By the mid-1950s, we had commercial jets capable of transporting hundreds of people across vast distances. Now that you know about the plane's history, you might be wondering how it works. First, the plane has to have a way of propulsion, whether it's by a propeller or a jet engine. Thrust is the name of the force that is pushing or pulling the plane via propeller or engine. The force opposing that is called drag. Drag is the force of the wind resistance that the plane experiences. On that same note, the other two opposing forces on a plane are its weight and the lift that the air creates passing over the wing. This is what causes flight. The propulsion system gains enough speed to allow for an ample amount of lift that is greater than the weight of the plane. The wing is designed to allow just the right amount of lift, and that amount can be adjusted with flaps. If a pilot wants to fly at a higher altitude, he tilts his wings back, allowing the maximum amount of lift. If he wants to descend, he tilts the wing down, creating a negative lift. At this point, the air passing over the wing actually pushes it down, allowing the whole plane to descend. While your paper airplanes had no way of propulsion, they still experienced the other three forces of drag, lift, and weight. Aircrafts without propulsion systems, also called gliders, fly by creating the most amount of lift possible. They do this using extremely large wings. As hot air rises, it catches the wide wings of the glider and creates lift. Your paper airplane did something similar. While it's not big enough to catch enough hot air for sustained flight, you still saw that it was more successful with wider wings. Thanks for watching. We hope this video has given you some insight on how important it is to test a hypothesis, and provided you with background information on the history of the airplane and how they work. Next time you pass an airport, think about how your paper airplane and actual airplanes are similar.